All right, let's dive in. We're going to talk about how AI is completely changing the game for astronomers, helping us make sense of the universe. But here's the catch, and it's a big one. How can we actually trust what an AI finds if we have no idea how it found it? That's the puzzle we're going to unpack today. It's pretty wild to think that just 100 years ago, we thought our Milky Way was pretty much the entire universe. That was it. Then, an astronomer named Edwin Hubble spent night after night at a massive telescope just staring at this little fuzzy patch called Andromeda. And he proved it wasn't a nebula, it was a whole other galaxy. That one observation, done entirely by hand, just completely blew our cosmic worldview wide open. It was a total triumph of human curiosity. Okay, now fast forward to today. The scale isn't just different, it's astronomical, literally. New telescopes, like the Vera C. Rubin Observatory, are about to unleash a flood of data measured in exabytes. We're talking billions of gigabytes. It's not a stream of information, it's a cosmic tsunami. There is no way any group of humans could ever sift through all of that by hand. So, to even have a chance at finding the incredible discoveries hidden in that data tsunami, astronomers have had to call in for backup. And that backup comes in the form of artificial intelligence. And what can these AI systems do? Well, the short answer is a ton. They can look at billions of galaxies and sort them by shape. They can hunt for these super rare things called gravitational lenses. They can even spot a star exploding, a supernova, in real time, just as it's happening. They're basically superhuman pattern finders, capable of seeing tiny signals that our human eyes would just scroll right past. And this is where speed becomes absolutely critical. Think about things that change in the night sky, like a supernova. If you want to study it, you have to find it fast. These new surveys spit out millions of potential alerts every single night. And AI has to sort through all that noise, figure out what's actually interesting, and tell astronomers where to point their big telescopes. And it has to do it in minutes. We just can't move that fast. Which brings us to the big central question. The AI gives us an answer. It says, hey, look over there, that's a supernova. But how did it know? If we can't follow its logic, how can we be sure it's a real discovery? This whole dilemma has a famous name. It's called the black box problem. And frankly, it's one of the biggest headaches when it comes to using advanced AI in any field of science. So what is a black box? Well, imagine a really complex AI. You feed it data, say a telescope image, and it gives you an answer. That's a spiral galaxy. The answer is usually super accurate. The problem is, what happened in between the input and the output is a total mystery. It's so complicated that even the people who built the AI don't fully understand its internal reasoning. And this chart really lays out the conflict perfectly. I mean, the entire scientific method is built on showing your work, right? You need evidence, you need a clear line of reasoning, you need other people to be able to reproduce your results. A black box AI, it just gives you the answer. It doesn't explain itself. For all we know, it could be cheating. Maybe it found a tiny flaw in the camera sensor that only appears in pictures of supernova. So just being accurate isn't good enough. We have to know why. But thankfully, this isn't a dead end. There's an entire field in computer science dedicated to prying open that black box and shedding some light inside. And that field is called explainable AI, or XAI for short. The whole goal here is pretty simple, really. Create tools and methods that let us peek inside the machine's brain and actually understand the why behind its decisions. I love this analogy because it makes the whole thing so clear. One of the coolest XAI techniques is basically like giving the AI a digital highlighter and asking it, okay, show me your work. On this image, what pixels did you look at that made you so sure this was a gravitational lens? The result is called a saliency map. And what do these highlighted maps tell us? Well, first, they let us check if the AI is doing its job properly. Is it focusing on the spiral arms of a galaxy like a scientist would, or is it looking at some weird glitch in the corner? That builds trust. But here's where it gets really exciting. Sometimes the AI highlights something a human scientist completely missed. And get this, in one real-world case, an XAI analysis pointed out a faint, flickering signal that led astronomers to discover a brand new pulsar hidden away in old data. And it's not just about images. We can ask the AI which specific data points it cared about the most. This chart, for example, shows something called feature importance. It's basically the AI telling us, hey, to decide this was a spiral galaxy, the most important thing to me was its specific color, way more important than its overall brightness or how lopsided it looked. This lets us check if the AI's logic lines up with what we know about physics. So, really, when you boil it all down, XAI gives us two incredible things. First is validation. We can finally confirm that the AI is thinking like a scientist. And second, and maybe even more powerful, is discovery. We can use the AI's unique perspective to find brand new things in the universe that we never would have seen on our own.
All of this is leading us to a totally new way of doing science. It's not just about humans using AI as a tool anymore. It's about AI becoming a true collaborator.
You know, the research this explainer is based on says it perfectly. Building AI that we can trust, using these explainable methods, isn't just some nice technical feature. It is absolutely essential if we want to make real progress in understanding our universe. So, at the end of the day, this whole effort isn't just about catching mistakes or making sure our algorithms don't go off the rails. It's about building a genuine partnership between human creativity and machine intelligence, one that can lead us to insights we couldn't possibly reach alone. Which leaves us with one final thing to think about. That next Edwin Hubble moment, that next discovery that completely changes how we see the universe, is it going to be made by a human? By an AI? Or, what seems most likely now, by a true partnership between the two, built on a solid foundation of trust? It's a pretty exciting future to imagine. Thanks for joining me.